All right, guys. So let's tackle sampling and surveys. We got to cover these things for your notes. So I pre-wrote this, so if you want to pause the video now and write this down, and I'll talk about it here in a second. Okay, so normally in class, this is what we would do. So I'll just kind of walk you through it. So I have this here, and it's got a bunch of different beads in it whatsoever. And I'll just go with the proportion of red. And so basically what would happen is I give you this here, okay? I give you this, and then you go ahead and you pick out the 10 red beads, or I should say 10 beads, and then you count the number of red that you have, and you create a proportion. So if you draw 12, and I don't know why I chose red, but there's no red ones in here. That's kind of goofy. But if I go over here and I draw 10, I'm just going to do 10 real quick, and I'll call purple 12. I'll call purple red 1, 2, 3, 4 out of 10. So I got 4 out of 10. So it's 0.4, and I put a dot right here. Okay? And so what happens is this bucket here would get passed around throughout the class, and you guys would sample this with 10. And as we're talking about different things, I would put a dot plot up. So we'd be working on stuff while we're doing this. And then I would have you guys go through and do the same thing and pull out 40 of them and count up the number of red ones in there, and then turn it into a proportion, and then you'd tell me what it was, and I'd put a dot plot. So this is kind of an activity that we would do in class. It's just drawing beads or drawing buttons or whatever we have in here out of here. And I already know what the actual proportion of buttons is. So after we finish, we look at this from here. So this is what's called results may vary. In other words, my result was 0.4, but somebody else's result was 0.8. So as you sample, your results are going to vary for every single sample that you do. That's the whole idea behind statistics. So what we're talking about is inference. So what do we mean by inference? So let's just look at this, and I'm not going to go into it in detail because we're going to do that in the next couple of chapters. So we know that we can create some sort of a dot plot here. Some sort of a symmetrical looking piece. And we can kind of go, right about here is X bar. So this is 0.4, that's 50. So let's say it's at 0.55. Okay? Let's say we get 0.55 out of it. So our X bar is estimated to be 0.55. So our idea is that we can infer something about the population of buttons in this bucket. Because we have our population. We took small samples of the population. Now we can infer something. What can we infer about that? We can infer that the amount of proportion in the whole bucket is 0.55 because it's right about the middle. Okay? So that's what statistics is all about. We're going to use what are called estimators. Estimators are X bar, standard deviation of X, and they are used to estimate the entire population. So this is our sample, and this is our population. We cannot sample the entire population most of the time. If we can, we don't even need to do half this stuff. Okay? We don't need to make as many dot plots because we can find the actual numbers. But since the population of these 300 or so beads that are in this thing, I don't want to sample all 300 beads, so I'm going to do 10 of them. And I came up with this graph, and I can say, oh, well then 0.55 is an estimate about the population. So X bar estimates mu, standard deviation of X bar estimates sigma, which is the standard deviation of the population. So we can infer something about the sample and apply it to the population as long as we have certain conditions and things in place. And that's the idea behind this chapter. How do we do that? How do we make sure that this estimator or this estimate is actually close enough to the population where we can say that they match. All right, so that's what we're talking about inference. Okay, so we can infer something about the population from the sample. And the samples are called estimators. All right, now, so this is a sample size of 10. So I had you guys do 10. We passed it around the classroom. Yay, good job, guys. Pass it around the classroom. We did 40. We're finishing up. We're talking about this. We do 40, and I put all your dot plots up. And then look what happens. Now, all of a sudden, we have a different looking dot plot because we increased the size of the sample. Now, all of a sudden, my normal graph is a lot steeper. And I'm looking at, right in there, is my X-bar estimator. So my X-bar estimator right there, let's call that 0.62. So this didn't change much. But remember, every time we sample, we're going to get a different number. So this X-bar is going to kind of fluctuate. But what changed? Our range or our distance from X-bar changed. So what does the size do, the increased sample size? It decreases our ability to make an error according to what the actual mean is. So we're talking about it actually decreases our standard deviation of X-bar because this is a measurement of error. How far away are we from the mean? Meaning, how far away did my number, how far away is my number from the mean? So 0.7 is 0.18 from here. We'll call that 0.75 is 0.13 from here. But up here, 0.85 is 0.3 away from this X-bar. So what we did is we decreased our margin of error by increasing our sample size. And basically the idea of margin of error, it's been in science, it's how far away from the right answer are you? And so we're going to get into how this attacks and our sample sizes change and how we make standard deviation and X-bar work for us to estimate the population. So that's how we increase sample size. Let me grab my eraser here, guys. So then, turn my phone off. I got a feeling it's going to blow up. I just heard it. All right, so here we go, guys. So if we got this, here we go. So sample frame. Let's just talk. We're going to talk about these last few things here. These are pretty dry but straightforward. Okay, sample frame. Let's talk about it as EUHS. So the sample frame is the list of people that you would grab. So I'm going to list out. So the sample frame, let's say, is EUHS students. And I have 5 seniors, 5 juniors, 5 sophomores, and 5 freshmen, let's say, okay? Oops. Well, this just don't even worry about 5 when we have freshmen. So we have a sample frame of seniors, juniors, sophomores, and freshmen. So that's where we're going to draw the sample from, okay? So this is where we're going to draw the sample from. So I'm going to pick, let's say, 40 again. I'm going to pick 40 from this sample frame. I'm going to grab them from here, okay? Make sure I'm going in the right direction for you guys. So we have our sample frame. That's literally all the sample frame is. The sample frame in here is the different colored beads, okay? Different colored beads. So this is where we're going to draw our sample from. So let's assume I go, you know what? I'm going to sample from let's see here. I'm going to sample from the U.S. history classes. Okay? So if I'm going to sample from the U.S. history classes, I'm going to pick random students because it's all about being random. So I'm going to do an SRS of history classes. What's the big problem with that? First of all, you did a simple random sample. You used your calculator right. You're like, I'm going to go sample Billy, and we've got so-and-so and so-and-so, so I got it good. I did a great job. The problem is you chose history classes. That means only juniors are going to get sampled. So you are undercovering the seniors, the sophomores, and the freshmen. So the idea of undercoverage is that some of the groups from the sample frame do not get chosen. You have to make sure all of the people in the sample frame, or all of the groups, or all the characteristics in the sample frame, they have to be able to be chosen. If you don't choose one of them, you have what's called undercoverage. You don't have a true ability to make an inference about the population. So that's the idea of undercoverage. So let's just say we walked in and we go, okay guys, I got my paper here. Who wants to answer a question? And then 5 people raise their hand. Well, that is what's called a voluntary response. Cool, they're going to answer the question. Nobody else wants to answer the question, and we walk outside. So the idea behind that is that is a sampling error. It's a sampling error. It's a pre-sample error. We may have undercoverage from that. It's voluntary response. There's some issues with that because they're volunteering. We're not randomly choosing somebody. So then the non-response is different. You walk into a class and you go, okay, student 1, student 2, we already chose you guys. Student 4, 3, and 5. I have 5 of you guys. You call their names out. You take them outside. You ask them the question, and 3 of them go, I don't want to answer that question. That's not a sampling error. That's just an error of non-response. They refuse to respond. So at that point, you have the option of saying, okay, thank you, and then you choose another student. Then don't worry about counting their results. They didn't give you an answer. You would just randomly choose another one. That's the difference between non-response and voluntary response. Voluntary is before you sample, an error before you sample, and then non-response is a non-sampling error on the other side. They just choose not to answer that. Response bias. This is our last one, guys. So I'll just choose right now. This is response bias here. So response bias. I have my Exeter stuff on, and I'm gonna use let's say Wilson Junior High versus Exeter High School. Okay, so I'm out in front of Save Mart, let's say, and I'm standing there with my clipboard, and I'm in my Exeter shirt. I got an Exeter EUHS hat on, Monarchs, everything, and then I'm standing there, and I go, okay, and I randomly choose people, and I ask them a question. Which school do you think is better at band, or something like that? Any question like that. And they're going to look at me, and I'm going to have EUHS gear on. You're more than likely going to have them answer EUHS because I'm in EUHS. So I'm actually steering their response towards EUHS. Okay? The next day, I go out there, and I've got Wilson attire on, and I ask them which is better, sampling new people. And then more than likely, they're going to choose Wilson because I'm dressed up in Wilson attire. So the idea of response bias is you present the question, the person asking the sample, anything that has to do with the question, you present it in a way that you're going to affect their response. Okay, that's the key piece. You're purposely affecting their response, which increases the probability that you won't be able to use inference, and the ability, it increases, well, it may not increase your margin of error, but you lose your ability to infer about the population. Now, if this is what our project is on this semester, I'm waiting to see how this all works out, but that's the idea. People have done stuff like they ask, like, they have Girl Scout cookies, and then they'll go, do you prefer Girl Scout cookies over Chips Ahoy? And then the next day they have Chips Ahoy out, and so you try to actually give them a response bias. That's the best way I can explain this stuff, guys. I'll see you soon.